Forgot my distribution down here. Control C. Control V. And we're going to make this 7. Oops, not T. I suck at typing. All right, so now we left Mr. Freeman and the Gator fan. How old?
20.
20. Uh-oh, she's going to mess us up. No, she's not going to mess us up too bad because she's right in here. So we're going to insert. And we're going to put 20 right here. And we got to check everything. What happens to our median? What happens to it? Does it change? Yep, it changes. So we got to figure all that out. So let's just take all this off. And let's just go back to the beginnings. Now, a lot of you thinking this is a lot of work here. You got to do this for every single node. When we do another homework problem in a minute, and I've got 5, 6, or 7 values, what do I need to pull up? My Excel spreadsheet that I saved, and all I got to do is type in the what? Numbers, and it gives me everything except for the mean or the mode, I mean median or the mode, depending on if it's observed or calculated. So you do what you want. All right, so let's just go ahead and do this. So we change that to 7, and let's do the summation here, which you probably already did it since I inserted it, but I want to check it just to make sure. And that number is equal to this number divided by this number. Median, n is equal to 7, so we just pick the what? The middle number. So it's equal to 19 again. I don't think we're ever going to get rid of 19. And the mode is going to be equal to the one that shows up the most, so it's still 19. I'm not going to worry about that. Range. Does the range change? No. Does the mid-range change? No. Those two doesn't change because these two didn't change. But look what it did to our standard deviation. It still went down. Why? Because she is included. See these right here? These are inclusive. Those are inclusive. Now if you throw my age in there, oh my God, it's going to go crazy. Why? The standard deviation is going to go crazy because I'm old as dirt. All right? So if I throw my age in there, it's going to really mess up. Because I just threw in more what? Variance. All right, let's do one more. Let's do 8.
Go down further.
Thank you. I'm trying to find somebody that's not 18. I'm trying to look. How old? Miss, let me get you, Mr. Murray. What? How much is? How old are you?
21.
21. So we'll throw him. Well, that ain't gonna help me. We'll just throw Hubie in here. Dang old. I gotta remember. Dang old. 47 or 48. One of the two. I'm born in December, so I have to think. Dang old 66. What's this year?
15, so you gave, it's 48.
48. Yeah, 48. So, dang old 48 right here. 48. And it didn't, now it did not include, because since I didn't insert it, it didn't include it. So we're going to have to do everything different. So let's just go ahead and do that. So, summation, dang old, throw it in there. And then dang old, take this moves up to 8. And then equals this guy divided by this guy. And there's that. And then we're going to subtract equals this guy, what is that, C83? C83 minus this guy, F4, and then equals all of them. And check, let's see, 7, that'd be right, 6, that'd be right. So those look right. Oops, we don't have this one. There we go. And check this, summation is all of these. That really gonna throw everything off. There we go. And what happened to my standard deviation? Went up to 10. I told you I'd throw a monkey wrench in it. I did, didn't I? Dang old started off with dang old 3 and 4 and dang old went to 10. Now, look, what does that 10 also do as far as your data? It says that it's what? Sloppy. I put the sloppy in there because I put the variance in there because now you got a gap right here of 20 years. Dang old 20-year gap.
The range and the mid-range aren't right.
I don't care about that. Y'all figure that out. Dang old. If y'all can't figure the range and mid-range out, I'll figure it out for you. Dang gummit. 48 minus, I'm just kidding. Make sure I get it right. There it is, 31, and then mid-range is going to be equal to parentheses, this guy plus this guy divided by 2. There you go. How about that? Is that good?
You divide by
You divide by
1.
1.
Divided by 1. I suck. Divided by 2. There you go. Now, that's nice and dandy. But now I just showed you how to screw up your data. Now, what do you do to make it tighter? Well, you include everybody. So, the best way to do this is start from the beginning. So, I'm going to go down here and dang old add another sheet. And we're just going to go down the list. And let's see if y'all can do this without screwing up, all right? I'm going to start over here. We're going to go this way, and then we're going to go this way. And we're going to go this way. Now, do I need to point? I hope I don't have to point it out to you, okay? We're going like this, all right? So, start with you.
17.
17,
21.
21, 19,
34.
34. There's the one I was looking for a while ago.
19.
19.
28.
See, I told you you didn't fit. I told you you didn't look like your age. 28. Did I get to do 28 right? Yeah. Okay. Next.
19.
19.
20.
20. 18.
17.
17.
18.
18.
18.
18.
18,
18.
21.
21.
21,
21.
19.
19.
20.
20.
20,
20.
20.
20.
19.
19.
19.
19. 20.
18.
18. 18.
21.
21.
20.
20. Is that it? All right, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 26? All right, so N is equal to 26. All right, what's the first thing we do? Put them in order. Dang old highlight them. Dang old go up here and hit data. Dang old sort. Look at there. But it's easier to do it on the calculator. All right, so now we got to find what? Your mean. So mean is equal to, and we got to go down here and sum these up. No coughing in class. All right, add those up. There's that number. So our mean is equal to this guy divided by this guy. There's our mean. So now, well, that's X. I don't like that being right on top of each other. So insert. That's X. And then what? X minus what?
X bar.
X bar, so that's equal to this guy divided by, or subtracted from, or this guy subtracted from that guy, F4. There's those numbers. And then X minus X bar is quantity what? Squared. That's supposed to be in parentheses, but y'all don't worry about it. I'm not going to worry about it right now. Squared. And we add those up. And just something else. If you add up all your difference of two squares, or X minus X bars, if you add them all up, what do you get? So what are we adding to the equation? 0. So you're really not hurting yourself. But that's in the derivation, and I don't go through the derivation unless y'all want me to, but I don't want to, so we're not going to do it. All right, so let's go and put all that in the center because I don't like it being on the right side. Here we go. All right, so, oh yeah, we got to go do our other stuff. 26. Is 26 odd or even? That's even. So we got to find our two middle numbers. Oh Lord, that'd be what? They don't half is 13. So that'd be number 13 and 14, would it not?
No, he's
No.
5.
Huh? It'd be 12. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, it'd be 12 and 13, would it not? Should be those two numbers right there. Let's just highlight those and count. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, I gotta go down one. Thank God it's not gonna be 19. It's gonna be these two numbers. Dang, it is gonna be 19. Darn it. Oh, we're going to get away from that. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 12 should be on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So 19 is our median. Equals, parentheses, this guy plus this guy divided by 2. What do you notice about the median and mean?
Very close.
Is it closer? Yeah. Mode. I have no idea, I don't really care, but I would assume it's 19. It might be 20.
They're all this between 18 and 19.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6.
By 18.
What's 18?
6.
1, 2, 3, 4, 5, 6. So we got a trimodal. So you could put trimodal, or you can say 18, comma, 19, comma, and 20. Now, why do you think the mean and the median is so close? Because you have 3 what? 3 modes. That's why it's so close. Mid-range, or range. Dang old, that's going to be equal to your highest number minus your what? Lowest number, which is 15, I'm sorry, 17. There. Mid-range. Thing will equal to parentheses this number plus this number divided by 2, and that's your mid-range. Variance and standard deviation. Well, your variance, we already got that number, so equals, parentheses, no, I don't want parentheses yet. Equals this number divided by parentheses, what? N minus what? 1, close parentheses. There's the variance, and then the standard deviation is going to be equal to the variance raised to the what?
45.
Well, dang old, the square root of 16 is 4. The square root of 9, that'd be around 3.5. It's going to be roughly around 3.5, somewhere in there. So, raised to the 0.5 power. It's a miracle. Now, what happened to the standard deviation? We started with what? When we started with the first 6, what was the standard deviation? 4.26 or 4.3. What happened to the standard deviation? We cut it down by what? 1. Because the variance did not show itself as much with 18, 19, and 20 being the what? The modes. And 21 was in there too. 21 was right there. So now let's do the standard, let's do the curve. Equals the mean in the middle. Oh, did I just minus it? Okay. And then equals this number plus what? And then equals this number raised to the what? Or plus the standard deviation, I'm not thinking. And then equals this number minus the standard deviation. And then equals this number minus standard deviation. Okay, so the 12-year-olds in here, y'all are unusual. And anybody above 28, that means me, is unusual. Now, y'all don't have anything to worry about 28 and 34 because y'all don't look 28 and 34, so y'all don't count. But I don't mean to make fun of anybody by their ages or anything like that. But this is the best way for you to see what you're actually doing with the standard deviation. What happened to the standard deviation? I mean, what happened to our normal curve when we added everybody in? It became more normal. Okay? Before, our curves was 12 to 30 and 12 to 28 and 13 to 27 and 3. I threw that one. I threw that one out of Wampus. To 44. That's what I'm good at. All right? But when we added everybody in and we did the whole class as a whole, what do you feel about this curve compared to the other curves? What do you feel about it? It's more accurate. So, what does the law of large numbers tell us? The more we include in our standard deviation or our statistics, the more we include the what? The better, the more accurate. So now, I can go to my president's report and I could say, you know, I think the average age of students at the Anderson campus is around 21 years old. How do I know that? Because I took a sample of one class. Now, why did I say 21? It says 20, Hubert. Well, you want to throw a little compensation in there just to help out, because you're never 100% accurate. All right, who's got questions? Now, the good thing about this is, once you've made, and you won't have one on the test like this, not with 30, 26 people. You will have some that are 5 and 6. So let's go to the homework and look up one. If I can find where all of this stuff is, there we go. Let's go to your homework, or I'll just go to the ebook. Let's see, I don't know what section we're on. Chapter 3, I think it's what, we're still in 3.3?
Okay.
I think 3.3 is standard deviation. I don't know if it's a frequency distribution or what, but we'll find out right quick. Okay. Nope. That's standard deviation, nope. Okay, there's a big one, but that's just finding the range, and, okay, it's finding, that's how many? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that's 48. I wouldn't give you one like that on a test. That's good for homework, but I wouldn't do, okay, what is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You need to work on your spreadsheets. If you get that one, you get one up to 10. Try and find one that's got 5 or 6. Good gosh. 1, 2, 3, 4, 5, 6, 7. Do we have 7? Okay, we can use this. So, how do you do it? Well, it says blah, 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 arrival time, blah, 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 find all this, find all the stuff. Okay, so you hit this, copy the clipboard, okay. Then it'll pull up your, how many do you have? 7? Just to make sure, pull it over in an area that you're not sure of, so you see what it looks like, and hit paste. There's your numbers. What do you got to do with those numbers? Put them in order, so you go up to your handy dandy data tab and hit that. Now you got them in order. Now you take those, Control C or Control X, and do what? And you're not done. Something happened. Okay, well, we'll figure it out. First of all, we need to add them all up. Probably don't like all those negatives for one thing. So let's add them all up. A lot of negatives. Does it want us to find the average?
Want us to find the range.
Oh, don't forget it then. I wanted to find the mean and standard deviation. I was fixing to say
Three
those
parts
negatives.
left to it after that.
Yeah, there's a couple parts.
So then-
Find the range, variance, and standard.
So you find the range first, and then
Yeah, but standard deviation can't be negative. That's what they're trying to show you. Okay, I don't want that one. That's not going to be a test question. When I find a test question, I'll let you know. Okay, there we go. There's a test question. Let me do that one. Copy the clipboard. 1, 2, 3, 4, 5, 6, 7. Let's try that one. That'd be a whole lot better to Control V. Put it in order. Control C and Control V. I don't know why it didn't. Usually I don't have to do this, so I might have messed it up when I put those negatives in there. So let me go back and check it. I never had this happen before. Equals this divided by this equals this. What is that? C52 minus this F4. There we go. Range equal to this guy minus this guy, and equals parentheses this guy plus this guy divided by 2. There. And variance should be correct, because all those should be right. I've never had that happen before. Sorry about that. Usually median 7 be that guy right there, 0.78. Equals 0.78. What's the mode? Mode, no mode. You put 0? Put nairn. Do that Dr. Gabati's class. Nairn. I do not do this stuff what that means. Alright. And there's your normal distribution. I'm gonna pull that back up because that should not have happened. What's the range? Hold on a minute. All right, what's the range? The range is 0.63.
No, 0.96.
Really? Hold on. $630 from what it looks like, unless they want. Hold on, let me make sure they want me. Let me carry these out to 5 or 6 digits. Should be 0.9 or 0.630. .630.
That's your mid-range.
Huh?
That's your mid-range.
What's my range?
0.960.
Point. Hang out of the way. It's a conspiracy. We all know whose fault it is. Bush's. 0.960. Hey, I got a star. My variance is 0.149. Fantastic. Sample standard deviation is 0.385. So I'm confident in myself. So I don't have to put smokestacks on my truck. All right. So now, what's it going to ask now? Oh, God. What would be the values of the measures of variations if the tuna sushi contained no mercury? I got to read the problem. I haven't read the problem. What would the values of the measures of variation of the tuna contain? Listed below are the amounts of mercury parts per million found in the range. What would the value? Okay. This is the parts per million. And it says, what would the values of the measures of variations contain no mercury? Well, they would all be what?
0.
I don't understand what question. I don't understand that. Okay, similar exercise. That's what I was getting at. All right, now I'm going to copy these, and this should work. Copy, okay. Over here, I'm just going to go right here and hit Control V. There's those, and I'm going to put them in order. Data. There, Control C, or Control X, and Control V. Okay, something's going on. I don't know what's going on. I usually don't have this problem. Usually I just copy them over and it gives us the numbers. So evidently something's wrong. I got to figure it out. I'll figure it out, but you get the point. The whole point is that the variance depends on what? What is a good measure of the variance? I just pointed to it right there. Standard deviation. In other words, it tells you whether your data is spread out all over the place or whether it's concentrated in one area. And you also can tell between the what? median, and the what? Mean, if your data is all over the place or if it's concentrated in one little area. All right. Now, what are we going to do the next couple of days? Okay, next couple of days, meaning the next time y'all come in. The next time y'all come in, we're going to go over 3.4. Now, 3.4 is like a 1 or a 2 compared to 3.3 with the frequency distribution and the listed data. Listed data and frequency distribution, and I'll write this on the board for you because you need to get this in perspective. Unit 1 test. What did I tell you that 80% of your test was going to include? Chapter 3. Those are the people that listen that day. 80% comes from chapter 3. And 20% comes from chapters 1 and 2, which is mostly what? Okay, so we're not going to worry about this unless y'all can't read. Okay, I'm not going to worry about this. But out of this 80%, most of this is going to be listed data, and I don't know what they call it, but listed data is what we just did today, and frequency distribution. Now when I say listed data and frequency distribution, that means that you're going to have, if you have 10 problems, and of course it's not going to be 10, usually I give 20, but if you have 10 problems on your test, 2 are going to come from chapters 1 and 2, and 8 are going to come from chapter 3. And I would be willing to bet you if 8 come from chapter 3, 6 of them are going to be listed data and frequency distribution. And what am I going to ask on listed data and frequency distribution? I'm going to ask you the mean and the what? Standard deviation. So those two things right there, mean and standard deviation, is going to make up 80% of 80% of your test pretty much. The other 2 or 3 problems that you're going to get, or 4 or 5 problems that you're going to get from chapter 3 are going to be in 3.4. And 3.4 is box plots. And 3.4 is what we're going to go over. Let me show you. 3.4. I don't need to, I still got a minute or two on it. I think 3 minutes. All right, some of y'all already having cardio infarctions. Y'all need to chill out. Box plots and percentiles. We're going to go over the percentiles and the quartiles. So that's what we're going to do when? Wednesday, I'm going over the last part of the what?